Hello, folks. Welcome to Rational Science, the only site on the internet that does physics. Everybody else does mathemagics. What is mathematics? Well, for this, to understand that, we got to go back a few hundred years ago, several hundred years ago. And, when humanity started out, they had to build buildings, and so people learned how to measure, and they developed what is known as geometry. One of the first times that man applied arithmetic, or you could say the beginnings of mathematics, and try to blend it with physics. And it was a rotten deal because they got all the foundations wrong in what we know as geometry today. And we receive our information about geometry primarily from the Greeks. And here's what a famous Greek said about geometry, or how high the Greeks had it, how high they esteemed geometry. And this is Mr. Plato, and he said, "Let no one ignorant of geometry enter," and or something to that effect. There's the sign. And so geometry was held in high esteem. And if you didn't know geometry, you were what? An ignoramus, and they would not let you in the club. And nothing has pretty much changed in the last 2,500 years. Um, well, we do it a little differently here. That's why, that's known as mathematics, because they have all the foundations wrong. They have the point and the line primarily as the underlying, you could call them structures, figures. They ain't figures, but that's what they have as foundation. Okay? Yeah. And this is the foundation of geometry, and this is the foundation of mathematical physics. And we have something different. We propose something different, and it's not let no one ignorant of geometry enter. We have something different here. This is what we propose. Instead, said, let no one unless blind and quadriplegic enter. If you use your eyes, if you use your hands, we're going to rip them off. Okay? You're not allowed to use your hands or your eyes in physics. Okay, so this is where we start. So we do it a little differently than Mr. Plato suggested here. Okay, and so yeah, we have a different way of approaching things. We're saying you do not need to know geometry. You do not need to know any math, because math can only describe. And what we're saying is we're going to be explaining, specifically in physics, we're going to be explaining mechanisms. Okay. And so these are a series of words that people who are not very smart use, and we discourage them, or else. Okay. And here it is. Here is a list of words that some people we call idiots, people who are very bright, exceedingly bright. They're enlightened, and they have big, big ideas. So we call them idiots from the word idiot, bigot. Okay. And those are the words. If anyone uses any of those words, uh, he's not doing physics at all. He's doing some kind of religion. Okay. And some of them are used as physical objects, and others are things that they do that they think are related to physics, okay, and are not. So if you find your word in there, one that you use to make your case, because I mention these words constantly, okay, but not to make my case. That's the point, okay. But people use these words, energy and mass and field and time and so on, to make their case, to explain a mechanism of physics. And we're saying that's irrational, okay. You can't use any of those words in physics. If you use them to make your case, well, look at the top end. You'll find out where you stand. Okay, you're a very, very exceedingly bright individual. Okay, and if you don't know why, well, that's because you never went to kindergarten physics. You didn't take the ABCs. You didn't learn them. Okay, And so some of the words there that are typically used by people who object or who oppose the establishment, mathematical physics, for example, the electric universe, okay? And what these people use is words such as plasma and electricity and ether and vortex. Those are typical words in their mouths. And so if you use any of those, well, now you know where you stand, okay? That's where you belong, okay? You cannot use those words as physical objects. And, I've had situations where, the electric universers said, what do you mean, Bill? You're saying that plasma is not a thing? Yeah, exactly. That's what I'm saying. Plasma is not a thing. What do you mean, huh? Electricity is not a thing? Exactly. Imagine the electric universe, electricity, which is part of their name, is not a thing. Dude, what do you mean it's not a thing? Stick your fingers in the outlet and you'll find out whether it's a thing. So this is how they prove in the electric universe what a thing is. You say, what is a baseball bat? And they say, well, let me show you. And they grab a baseball bat and hit themselves on the head. See, if you can hit yourself on the head, it's a thing. That's more or less the logic these people use. And so they say, if you want to prove to yourself that electricity is a thing, stick your fingers in an outlet. So this is how they do it in the electric universe. Well, we don't do it like that in science. And again, you got to take kindergarten physics. You could call it physics 101. And so you learn, what a thing is and what a non-thing is, okay? You have to be able to distinguish, first day of class, okay? You should be able to distinguish between concepts and objects. He who cannot is not a physicist, he's just wasting his time, okay? So the first rule of the game is to distinguish things from concepts. Okay, and that's what the electric universe has never done. Neither has the establishment, for that matter. Okay, so here we have some of the people in the electric universe. If you start using some of those words, you're going to end up in electric universe prison. You'll never get out. You'll be running around the circles constantly. Why? Because here it is. These are their famous words. Okay, you have things such as the vortex, and you have the waves. They have all kinds of waves: transverse waves, spherical waves, electricity. These are the words they're going to fill you with. And there you have the famous plasma ball. Okay. Yeah, these are the things that surround you and keep you imprisoned in electric universe prison. Okay. So if you don't want a life sentence there, get away from all of these words. None of these have anything to do with physics or with science. Okay. Moving on here. Here we have a couple examples of people who think they are very bright, very exceedingly bright, exceedingly enlightened. Okay. One fellow says, the pull is to the known point in counter space. Oh, counter space. Talking about magnets here, how a magnet attracts another. Says the pull, okay, is towards counter space, okay, between two magnets. Their forces combine before they join. There's no magic. So far, it sounds like magic to me. I don't know what this counter space is. The only counter space I recognize is, when I put my beer on the counter at the bar, if there's too many bottles and things there, then I have no counter space. But if I can place my beer there, then I have counter space. Okay, so that's the way I look at it. And here you have a vision of that. Okay, what this fellow is saying. He's saying that you combine and join the forces. So what is it that he's combining and joining? What forces? There's only push and pull. So is he saying that he's combining push with pull somehow, or maybe two pushes or two pulls? Is that how two magnets come together? Okay, so again, it's these irrational explanations that these people give for common phenomena that really boggle the mind. Okay, and here's another fellow who also introduces counter space. Okay, he says counter space is small scale relative to large scale, right? So it's small. We have counter space which is small. You have counter space, I guess, that is large. I don't know. It is the inverse of space. Okay, so space is that black stuff, I guess, right? That's between the Earth and the Moon. So counter space is what? Meaning space is nothing. Is he saying that counter space is something? Is a thing? What is counter space? He says, don't worry about it. It's not complicated. Don't worry about it. That's how he dismisses it. He's got no problem with counter space. He just uses words. He doesn't even know what he's talking about. He could be talking about X, Y, or Z. And he says, it's an X. Oh, what's an X? Well, it's the opposite of a Y. Oh, okay. And what is a Y? Well, don't worry about it. It's not important anyways. Okay, yeah, so here's a definition that I've got, I think, for counter space. Is space left on the counter after one mug of beer is placed on it. Okay, so that's what I think counter space is. Yeah, these people use these words and they never define them. We have this fellow out there, you know, the who I call the Buddha, okay, and he has his little show and he talks about counter space constantly. He put it in his book, and I mean, you know, I looked throughout his book to find out what counter space is, and all he's got is either synonyms or irrationalities. He always ends up with the word field, which is nonsense. You saw that one of the first words there in the list at the beginning here of my talk today. Field, you don't want to use the word field, okay? You can't say field does this, or does that. You can't use the word field at all in any way, shape, or form. Okay, so don't tell me counter space is a field, which is the opposite of space, and all these guys just chase their tails around. Okay, so give me a second here. Yeah. So what is science about? I mean, if these guys aren't doing science, what is science? Well, here's a summary, okay? In science, the first word we have to define is the word definition. We have to know what a definition is, okay? And you have to define the word definition scientifically, okay? So that's the first one. If you can't do it, well, you can't even begin to do science, okay? And a lot of people, you know, dismiss all that, say, hey, you know, I came here to do science, not semantics. And yeah, poor fellows. You know, this is not grammar. This is not semantic. This is presenting the foundations of science. That's what we're doing here, okay? So you have to set, or you have to formulate the foundations of science. That's what it's about. And definition is one of the words you need to define. You need to know what a scientific definition is, okay? And then in physics, which is a branch of science, okay, the first word you need to define is an object. You need to know what an object is, okay, and you have to distinguish it from concepts, okay. Why? Because we can't do physics without an object. There's no phenomenon that can occur. There's no phenomenon that you can explain unless you put an object on the screen or use it in some way in your presentation. You need an object to do physics. Without objects, there would be nothing happening in the universe. Okay? So you need a thing. For that, you need to know what a thing is. You need to define it. Okay, and again, because you're going to be explaining a mechanism, right, a cause. What is the purpose of physics? Is to explain how the universe works. By how, we don't mean a description. We mean an explanation. Okay, we need to have a physical interpretation of how the universe works. You need to explain what is the mechanism, the cause of gravity, for example, or how a magnet attracts another, meaning the cause. What's making that happen, okay? And so physics is unrelated to mathematics. In physics, we do not use mathematics. Mathematics is not the language of physics. The language of physics is illustration, and to illustrate, you need an object. Okay? That's what we preach here. Okay? And in physics, we don't do experiments. We don't do any measurements. Okay? So anyone doing measurements, experiments, all they're doing is descriptions. Okay? We need to explain the results of an experiment. That's what we do in physics. But to take a measurement, anybody can measure a table, even a 10-year-old. Does that make him a physicist because he can measure a table? Because he ran an experiment, he doesn't understand what he did. He just poured one liquid into another and they turned from red to blue. And he doesn't understand what happened. He just said, oh, I did an experiment. Great. I mean, you know, does that mean you understood that you can explain something? So no, we don't do experiments or measurements. What we do is explain the results of experiments. You have to explain the experiment, the cause, not do it. And the second word you need to define in physics, which is important, which is exist. Okay, you need to know what exist means because exist is the science of existence. The reason deists, atheists, and agnostics go around in circles and have been going around in circles for who knows how long is because none of them ever defined the word exist. To this day, we have no definition of the word exist. All you will find in the dictionaries are synonyms and long explanations. Like if you go to the Stanford Encyclopedia of Philosophy, oh man, they'll talk about exist until you die, and at no point do they define it. They cannot tell you what exist means, and they never have. That's why people are still wondering, does God exist? Do you believe in God? And they keep going around in circles. In science, it's very simple. We define the word exist. If it meets the definition, it exists by definition. It exists pursuant to the definition. That's how straightforward it is. Anyways, we had this fellow who criticized my science series that I started, and we'll get to him in a minute. First, I want to mention the who the winner this week is for the Idiot Honor Roll. Talking about idiots, hey, we have the Idiot Honor Roll, and it was a big competition this week. I mean, people tried very hard to win, and I gave it to this fellow only because he mentioned something that several people have mentioned along the way. We have a little history on this issue, and so I thought I'd put him up there in lights so that people understand it. Okay, so what did this fellow say? Let's see if I can get this here. Give me a second. Okay, fellow says, in the rote theory, okay, not a theory, it's a hypothesis, but okay, what is the explanation for the cause of the pull down to the earth? Okay, if everything is connected by ropes, electromagnetic ropes, right? Why is it that all the ropes that connect to other stars, planets, don't also pull on objects? Okay, there's several people who said, they said, when a spoon falls, I say, well, because the spoon is connected to every atom of the spoon is connected to every atom, in the earth that comprises the earth. And so the question is, they say, this fellow says, well, how about the ropes that connect us to everything else in the universe? Don't they pull the spoon upwards? Should they? And I guess that's why I won the prize this week. Okay, so let's go slowly for those who have problems. Now, there's two possibilities. The fellow either jumped the gun, okay, and just asked the question without thinking, or maybe he actually doesn't understand and is simply an ignoramus. I guess he never went to high school, because in high school they teach you something called mathematical physics, okay, and one of the first things you learn is Newton's equation. Don't they understand that Newton's equation? Don't they relate to it at all? Okay, so this is what it's all about. Here you have the Earth, the moon, and an astronaut over there on the right. Okay, and the astronaut's close to the Earth. Okay, and so the question is, who would he be attracted to the Earth or the moon? You might say, well, to the Earth because it's bigger, it's got more mass. Okay, that's what Newton's equation would say. But how about the distance? Like under the rope model, you have all these connections from the astronaut to the Earth, okay? And you also have connections from the astronaut to the moon, okay? And here it is, okay? So he's connected to both the moon and the Earth by electromagnetic ropes. But now you look at the equation, and hopefully you should be able to determine that it's not mass that's the big ingredient in the equation. It's that distance squared on the bottom. Distance plays an enormous role in that equation. The more distance you have, mass can become even almost irrelevant. It doesn't matter how big the mass is if it's on the other side of the universe. Okay, you will have no effect on that mass because the distance is so great. And here you have, for example, in this case, you have a star, okay, and it's far away, okay, and every atom in that star is tied or bound to every atom in your body, in every single atom. They're all connected. But they're so far away that you can almost consider um, all those ropes as a single coaxial, as if it were a single thread. It's got very little influence to you, even though every atom in your body is connected to every atom of that star. And the reason you can see the star is that you're looking along the ropes. In other words, the rope torques from that atom in that star to an atom in your eye, and that's why you can see it. Otherwise, how do you think Mother Nature does this? Does it do it without anything between your eye and that star? Are you saying that we have this faraway star, it's sending little photons to your eye? Don't those photons swerve in space? Okay, don't they turn around the corner? According to Einstein, you've got all these um, potholes caused by gravity. And shouldn't those photons just go in every which way except straight? Okay, so here we're saying no, you have a straight line of direction to that star, and you have it through the ropes. So you have, this situation. I'm connected to every atom in your body through the ropes. Okay, so and the ropes are always taut. They're tight. Okay, pulled tight, not flexible. Okay, all they do is torque in place. That's why they're so fast, because torsion is the fastest thing known to man. And so that's our theory. But yeah, you have to apply Newton's equation. And for that, you got to look at distance. So yeah, people who ask that question can look at the honor roll, and maybe they'll find their answer there. Okay. Okay, let's go with this science fellow. He said the other day, he criticized my theory, and he was looking at the word hypothesis. He was saying that hypotheses need to be tested. Okay, let's listen to his own words. Okay, they come out of his own mouth. So I'm gonna set this in motion here. Give me a second. Here goes. Listen carefully. Here goes. Questions and issues addressed in this rebuttal are: what is a hypothesis? And is a hypothesis testable?
You need to be able to formulate a hypothesis, and that hypothesis needs to be testable. And then you have to test that hypothesis.
Okay, so he's saying we have to test the hypothesis. How do you test the hypothesis? Well, before we can test it, we have to figure out what a hypothesis is. Then maybe we can decide how we're going to test it with an experiment. I mean, I don't know. Let's find out. Let's find out what a hypothesis is first, okay? And so we look at the word, we look it up, and we find all these versions there. That it's a purpose, a question, a tentative guess, hunch, uh, talking about a prediction also. It's an assumption, an explanation. You present evidence for it so you can test it, I guess, right? It's a theory, a provisional explanation, a tentative theory, and another fellow says it's data analysis. I mean, are all these synonyms that hypothesis is everything? What the hell is a hypothesis? I mean, here I summarize it for you, okay? Will the real hypothesis please stand up? Okay, because they have all these versions of what a hypothesis is. I think they lost track of what they're talking about after a while. Okay, and so the question is, is a hypothesis the same thing as a purpose? And if it's a purpose, is it the same thing as a prediction? If it's not a prediction, then what is it? What are we talking about here? We got a real problem here because they have all these versions of what a hypothesis is. Okay, is an assumption the same thing as an explanation? Is a question the same thing as a tentative guess? I mean, they have all these versions. What is a hypothesis? And I can tell you right now, mathematics has no idea what a hypothesis is. They have so many versions of it that people have lost track of what a hypothesis is. But most people define it as this, and these are definitions you'll find out there. Okay, most of them essentially say that it's a tentative explanation. This is more or less where most people converge upon when they officially, or define the word hypothesis. And there you see all the versions. Okay, okay. So is that what a hypothesis is? Is just all these versions of explanations, possible explanations, a proposed explanation, etc. Well, when you go to a scientific dictionary there, Britannica, it says hypothesis differs fundamentally from theories. My God, they're saying it's a theory over here on the left, and on the right they're saying, oh, by the way, it's different. Okay, let's see what's different about them. It says, whereas the former is a specific tentative explanation, serves as the main tool by which scientists gather data, the latter is a broad general explanation that incorporates data from many different scientific investigations. So I guess what they're saying here is that in one case it's an explanation from one fella or collected from information or data that he collected in his basement, and the other explanation, the theory, that's from many basements. Great. I mean, is this the difference? One basement versus many basements? Is that what the difference between a hypothesis and a theory? Okay, so we have a problem there. And then to top it off, we have this fellow. And let me, no, got the wrong way. Hold it. Have this fellow here. And he's from a university. He's a emeritus professor. And his name is Donald Simonek. And he says, science doesn't explain. Science describes. Because that's what math can do. That's the only thing math can do, describe. And so if science doesn't explain, we started out saying, well, what is a hypothesis? It's an explanation, a tentative explanation. They have all these versions, actually. So it's a prediction, it's an assumption, it's a data collection, who knows what else. Then they say, well, no, it's an explanation. Different kinds of explanation, but it's an explanation. Great. And now they say, well, there's a difference between explanation and hypothesis. A hypothesis, when one guy has explanation, what many people have, apparently, that's what it's all about, one versus many. And now this guy said, oh, by the way, we don't explain anything. So we went full circle. What did you learn today in school, son? Not much, Dad, not much. Okay, so we don't know what a hypothesis is, but if it's an explanation, this fellow says we don't explain. So at this point, I don't know what science is about. If science is about explaining or about testing hypotheses and hypothesis and explanation, and we don't explain. Great. Okay. Okay, but let's assume that it's an explanation, and this fellow says we're going to test that. We should test the hypothesis. Okay, let's test it. Let's see how we're going to test it. And here's an example. This is general relativity, gravity under general relativity. Okay. And these are confirmations of the explanations for gravity according to, general relativity. These are things that they claim they confirmed through experiments. Okay, so general relativity, they say, is the most confirmed theory out there, and it's confirmed by all these experiments. Okay, let's find out. Let's listen to what these people have to say. So here's the first one, okay, Mercury's perihelion shift, okay. And this is what you find out there. It says, Mercury's perihelion shift. Einstein's 1915 general theory accounted for Mercury's anomalous precession. Einstein wrote to Michael Basil, perihelion motions explained quantitatively. You will be astonished. Yeah, I'm already astonished because I don't know how you can explain quantitatively. What does that mean? You either explain or you describe. Quantitative is only descriptions. So I guess Einstein didn't understand the difference between an explanation and a description either. Okay? And then in general relativity, this change of orientation of the orbital ellipse within its orbital plane is explained by gravitation being mediated by what? The curvature of time. The curvature of time. There you see it, warp time. So they're explaining the orbit of Mercury by saying that time has curvature, time has been warped, time is bent, as this fellow said the other day. Is this what it's all about? Saying that, is this does this sound rational to you to say that time is bent, time is warped? That explains why Mercury rolls around in these ellipses, shifting ellipses? I mean, does this make any sense? How did they confirm that? Observation, experiment, testing the hypothesis. Is that how they did it? Let's move on. Light bending, gravitational lensing. This is another confirmation of relativity. Let's see how they did this one. This got to be fun. Okay, here it is. Okay, light bending. The bending of light is in gravitational fields. All this from the Wikipedia, by the way. Experiments showing light bending in accordance with the predictions of general relativity were performed in 1919. Okay, I don't know what experiment they could have done or what predictions these were, but how do you bend light? Einstein became the first to calculate the correct value of light bending. And that's after Newton, gravity predicts that starlight will bend around a massive object. So how do you bend a wave, transverse wave? Assuming that's what, because they're saying that these gravity, they talk about gravitational waves. So how do you bend these waves? And how do you bend photons, assuming, photons are the same thing as gravitons or vice versa, and you have all these particles. You could be either photons, gravitons, or any particle, muons if you want. I mean, or Higgs. How do you bend these things? If we're talking about particles or waves, how do you bend them? Okay, so again, I don't know how they proved this. They say these are the confirmations that they proved it through experiments. How do you prove that you're going to bend light? How are you going to prove that you bend gravity? How are you going to prove that you bend magnetism? What sense does any of that make? How do you do that? How do you test the hypothesis? Okay, they do space bending. Okay, let's find out what that's all about. Space bending. That's got to be fun. Here it is. If you want anything bent, you should call on Einie Service. Okay, he bends anything. He bends bananas, hammocks, whatever you got. Okay, here it says Einstein theory suggested that large objects bend the space around them. Okay, I don't know how you can bend space if it's not a physical object, but this is the way they treat it. Massive celestial bodies like the Earth drag their local space-time around with them as they rotate. That comes out of NASA. Okay, how do you, gravity probe B experiment, by the way. And so the question is, how does the Earth drag a concept such as time around? What sense does this make? How did they prove that? And they say, well, they sent some gyroscopes there and they moved. Okay, so the gyroscopes moved, and so they inferred, they didn't prove anything, they inferred that the gyroscopes moved, oscillated, or whatever, moved out of their position because they rubbed their elbows against space. How did they do that? No, they made an assumption that space is a physical object, and the gyroscope rubbed its elbow against the this thing called space, or time maybe. Maybe it was against time that it scraped its elbow. I mean, what sense does it make to say that they confirmed experimentally that Earth drags time around itself? What is this? This is nonsense, or space. It doesn't really matter. Okay, how about time? Bending time. Oh man, that's got to be just as good. Okay, here it is. And he bends the seconds. Good old Einie there, strongman Einie. Does gravity bend time? In Quora, answering says, if you consider time and space to be the same thing, then yes. And that's what Hawking told us. He says, in relativity, there is no real distinction between the space and time coordinates. Yay. And then in a stack exchange, another prominent site who supposedly does at least mathematical physics, okay? Gravity is the bending of time. Yeah, these people bend time. How did they confirm all this? How did they test this hypothesis when you cannot even make sense of it? I mean, before you do an experiment, hopefully you do a design of experiment. And this fellow is saying, go test a hypothesis. How do you test a hypothesis such as that you're going to bend time, or you're going to bend space, or you're going to warp the field, or bend the, or curve the wave, or a series of gravitons or photons, particles? How do you do this? What confirmations are there? How do you test the hypothesis? Please give me a mechanism how you test a hypothesis, and we're going to find out whether you did anything physical, whether you explained anything rationally. Okay, that's the issue. So no, we don't test hypothesis, whatever that means. Okay, why haven't these people zeroed in? You know, the mathematics. Why haven't they ever figured out gravity? Well, they haven't figured out not only gravity, but any of the invisible, intangible uh, uh, phenomena out there. You know, you have gravity, you have magnetism, you have electricity, the atom. You can't see in there. It's so tiny or simply out, you know, like in the case of magnetism, I always show this. Two magnets, right? The two little circles there. And you can see that there's absolutely nothing between them, okay? Nothing that you can touch or see. And you can just do this at home. I mean, you don't have to believe what I'm saying here. I'm just saying, put your hand between two magnets, you won't feel or see anything. Okay? So how do you test that? Do you go to the lab and do what? Please tell me what experiment you can think of in which you're going to detect what magnetism is, what that invisible mediator looks like. That's what we're trying to find out. And so here, let me show you a couple of things here that you can see what the problem was for the last 2,500 years, why they haven't figured any of this out. Here you see a chariot, okay, a fellow charioteer, and he's got his horse tied to his buggy there, okay, his little chariot. And so we understand it. We look at it and we say, well, why does the chariot move together with a horse? And you say, well, because somehow the horse is bound to the chariot, or the chariot bound to the horse. They're in physical contact. That's why this is not surprising. We're used to these kinds of things every day, you know, and we look at this and we say, okay, I understand it. I don't need to go to college to understand why the cart moved there, okay? Okay, so here, let's look at it again now. Here's this situation, okay? And now you say, well, why is the cart moving now? You say, whoa, that's scary. I mean, you know, how is it that the horse is pulling on the cart? Assuming that's what's happening, right? Maybe something's pushing on the cart from behind, but we don't see anything in front or behind the cart. So why is the cart moving together with a horse? And so people have problems here because they say, oh man, this is weird. This is out of this world. I can't see or touch, if you were there, right? You know, whatever's the bond between the horse and the charioteer there, or the chariot, right? You know, you can't see what's connecting them. And so this is when it becomes really scary. So let's look at it again, side by side, okay? Or up and down, okay? On the top you have the one that's connected, and on the bottom you have one that's not connected. And the top one we have no problem understanding and accepting. The problem we have is with the bottom one, okay? And so this is the issue. The issue is the only reason you cannot explain gravity, the only reason you cannot explain magnetism, is you cannot see the invisible things that are mediating between two magnets, or between the earth and the spoon in case of the spoon falling to earth, gravity. And so, and all you had to do is do what you see here. Once you make the reins, you know, and so on, the thing that's connecting the horse to the buggy there, once you make that visible, then it's not a mystery. It's kid stuff. You don't need math. You don't need to go to college. You can just look and say, okay, I can explain that. It's tied. You know, that's why the cart's moving. The only reason you would not be able to is if you have the bottom situation where you don't have a connection between the horse and the charioteer. Okay, so this is the issue. The issue is that the only reason these people have been stumped throughout history of why the spoon falls to earth is because they can't see or touch the mediators. Why have they been stumped by magnetism? You know, because they can't see or touch the mediators. If you make the mediators visible and show a mechanism of how it's done, now people say, that's kid stuff. Anybody can understand that. The only reason is you can't see the mediators. Period. We're done. Okay? So there's nothing to test. What are you going to test as far as something that is invisible or intangible. I mean, this individual says, go and test the hypothesis. Okay, we go to the lab. What do you want me to do? How am I supposed to test the hypothesis here? Okay, what am I supposed to do? Please tell me how you would test the hypothesis. The hypothesis is what? That particles, what was it, green pixies attract these two things? Great. Show me in the lab, or wherever you want to test it. I mean, I don't know. Show me how a magnet attracts another, or how a pencil, falls to earth. Okay, with pixies, whatever you want, particles, waves. Show me the mechanism. Test the hypothesis all you want, then come back and tell me this is what the mechanism is. Tell me how it was done, how the magic trick was done. That's what we want to understand. Okay. Yeah. So these are my conclusions. Okay. Hypothesis is not a theory. It's not a theory. Hypothesis is an assumption. An assumption is not an explanation, which is what a theory is. Okay. And description is not an explanation. And I talked about that in the past. I'll be talking about more of that in the future, but right now I'm not going to get into that. But no, anyone who thinks that an explanation is a series of descriptions, well, he's got something else coming, and he should go to square number one. What was it? The idiot honor roll there, and find out if a description is the same thing as a explanation. Okay, explanation, what is it? It's a mechanism. You have to explain the cause, okay? What is an explanation? In physics, right? It's a physical interpretation. What caused something to happen? It's not how in the sense of, let me describe it for you. No, it's how in the sense of, let me explain it, how it worked. What caused it to happen? That's what a mechanism is, and that's what physics is about, explaining the mechanism. That's known as a physical interpretation. But even assuming we concede to this fellow and say, okay, you're going to test the hypothesis, fine. And what is a hypothesis? Well, I guess he's going to say it's an explanation of some kind, a tentative one, whatever, I don't care. But it's an explanation, one way or another. I don't care what adjective you put in front or adverb. Okay, fine. So the first issue is verification. Assuming we go in there and we falsify, we test, we verify, all you did was believe. You changed someone's belief. Okay, you just changed his opinion. You haven't done any more than that. You just gave him your opinion, your version. You say, I tested the hypothesis. Okay, you tested it. Great. What did you come out with? Well, I came up with this. And what you're telling the fellow is, I want you to believe in my theory. I want you to believe in my hypothesis, in the way I explain this. And the guy says, yeah, this guy believes and this guy doesn't. So all you did was affect belief. Science is not belief. So we don't test hypothesis, even if a hypothesis is an explanation. And even if you tested it, all you did was try to convince something of your version of events. That's all you did. Okay? And then, with all these tests, experiments, what did they come up with? They came up with irrational explanations, physical interpretations for the ones that I just mentioned. Gravity primarily in this case. And what have they done? What have they explained by saying space-time is warped? Is that a rational explanation? So here they tested the hypothesis. They went out there. They did the experiment. They say we confirmed that the hypothesis was tested, that it was verified. I don't know what the language is in mathematics. Okay, so you did all that. What did you come up with? Well, they came up with warped time. That's gravity, warped time. Great. Seconds are warped. The minutes are warped. The years are warped. What kind of explanation is that? It's irrational totally. So all their testing, all their experiments only led them to irrational explanation, to irrationalities. Okay, and you can't test, if you're going to test the explanation, you can't test what is invisible and intangible. Magnetism, gravity, you can't test that. All you can do is make an assumption of what you think is in there, what physical object is mediating the transaction. And based on that assumption, you give an explanation so that someone understands the mechanism. Okay, that we can all follow. But other than that, what are you going to test? What experiment are you going to run for this, again, here's the experiment. This is the only experiment you need for gravity. You let go of the pencil, and it falls down. Okay, here on Earth. Okay, so it falls downwards. Great. That's the only experiment you did. You did the experiment. Now come back and tell us why. That's what you got to do. But to say you did the experiment, I let go of the pen a million times to make it repeatable, verifiable. Yeah. So I measured. I know the speed. Great. And any what idiot can do that? No, we want a scientist. We want someone who can explain what caused the pencil to fall downwards. Okay? And no, so we don't need to test a hypothesis. What we do in science, we visualize. We attempt to visualize the mechanism. And for that, all you need to have is maybe a beer on your right hand. If you're left-handed, you can use your left, I guess. And visualize, try to imagine how Mother Nature could be doing these magic tricks. I mean, how would you do it if you go and watch a magician on stage? He cuts the lady in half, or does something with balloons and doves. Takes a handkerchief maybe, and the dove comes out. Makes a magic trick, and you say, "Oh man, how did he do that?" And okay, and so you try to figure out how he did it. That's how you do it. What are you going to go there with a measuring rod and say, let me measure this? Okay, I'm going to measure the hanky that you use. I'm going to measure the dove, see if he fits in there. And I mean, no. The way you do it, you sit down there with the audience. You try to visualize how the guy could have done the trick. And that's how science works. That's how physics works. You have to try to figure out how the universe works as a spectator. The only way you can do that for invisible, intangible things is visualizing. Okay, so starting tomorrow, everybody try to visualize. Okay, well, let's get to some of the Moonies. Okay, we got Moonies. Who's a Moonie? Moonie guy is a person who thinks we didn't go to the moon. And the other day, I sort of started becoming a Moonie a little bit. Why? Because they asked me to watch a documentary, 3-hour documentary, that went over all the different aspects that the Moonies say are evidence that we did not go to the moon. And why do I have doubts now? And I'm not saying that we didn't go to the moon, that we did go to the moon. I still think we did, but I'm not 100% sure anymore. And the reason is very simple. First of all, I'm open-minded, and I'm willing to consider other possibilities. I don't consider whether Santa Claus is in the North Pole. I don't think I'm going to make a trip there to verify whether Santa Claus is there or not. Okay, and I won't do it either because I'm worried that I may actually find Santa Claus. With Rudolph and Dancer and Prancer. When I come back, they might put me away, okay? So I'm worried about that. I'm more worried about finding Santa than not finding Santa, okay? So I don't go to verify these things. I don't go to the flat Earth, to the edge of the flat Earth to find out if there's a wall of ice there, and the militias, government militias or whatever, they're there to protect so that I won't see the wall. No, I won't go to the Antarctica just to find out, that the Earth is flat, okay? I don't do those things. But here's a different situation. These people presented their case, some things which I cannot explain, okay? And until I can explain, I can't say that I'm 100% sure that we went to the moon. I think we did for other reasons, which I'll be discussing now, but all I'm saying is, they did put the little seed of doubt in me, okay, on some things, simply because I cannot explain them myself, okay. So one fellow says, he starts out, he says the following, he says, make separate videos for such stuff at least. Even better, a whole different channel. In the chat, we were saying that get back on topic already. What the hell is this channel anyways? Irrational conspiracies? Well, no, we got to put it in the right perspective, okay? There are different aspects to the Mooney issue. Here they are, okay? Let me summarize them here. There's the politics and conspiracy aspect of this, okay? That's one issue. There's also the, you can criticize the assumptions, okay, whether some of those assumptions are correct or not. So that's a way of attacking the hypothesis in your theory. Okay, what are the hypotheses, the assumptions that you make. Okay, and then there's the scientific aspect, the theories, etc. Where you have, how did we get to the moon? Um, did we have booster rockets that took us there? Even if it was filmed, let's assume it was all a hoax. Okay, how did they do the filming? Isn't that a valid question of physics? Because we're talking about, again, not the political aspect there. We're saying, how did they do the filming so that they were able to convince you that we went to the moon? Okay, how did they do all these tricks? It's just like a magic trick that you see the magician perform on stage. You try to figure out how he tricked you, and that is science. You're saying, how did he do that? I want to know. I want to understand that. And this is the same thing. Even if they fooled you, even if it's a hoax, you want to say, okay, how did they do that? Okay, so that part is scientific. So it's not all just conspiracy. Okay, there are conspiracies and there are conspiracies. Okay, and there are several aspects of the moon landing which are worthy of study from a scientific perspective. That's all I'm saying. Okay, and again, I'm suggesting people keep an open mind. Okay, why did I change my mind a little bit? And it's got to do with this. Here, let me show it to you one more time. Okay, here it goes. Pay attention. Listen carefully. Here it goes.
Then, on September 16, they appear for a press conference in front of the global members of the press, who welcome them with a standing ovation. Everyone expects to see three absolute heroes radiating with happiness and pride for their incredible achievement. But their faces appear somber, tense, somehow preoccupied instead. They seem uncomfortable, and there are several truly embarrassing moments during the event. When the three astronauts are asked the meaning of a mission that has brought mankind on another celestial body for the first time, the three don't seem too eager nor too enthusiastic about answering the question.
Many of us and many other people in many places have speculated on the meaning of this first landing on another body in space. Would each of you give us your estimate of what is the meaning of this to all of us?
And when Armstrong describes their achievement as the beginning of a new era, he seems more like a person forced to read from a script than someone actually convinced of his own words.
The entire program, it's a beginning of a new age.
Okay, so the way I look at this is, to me, they were ashamed. This is the impression. I mean, I'm no psychologist, I'm no shrink, but I can tell you just my impression. These people are hiding something. This is not the attitude that you have when you went to the moon and came back. This is not the gung-ho attitude that you're alive because you came back. And here you have all these people clapping and saying, you guys are hero, and the guy are kind of looking at themselves and saying, are we heroes? So this was telling. The other one was the fact that, they chased after them to swear on the Bible, and none of them would. And then, Neil Armstrong has appeared only in one reunion, and he was very somber again, very bad attitude there, shameful attitude if you ask me. And he never appeared again, maybe because the United States government did not invite him, saying that this guy might spill the beans, he's just too obvious. So this was very telling in my opinion. Now, one possibility is that maybe, the first moon landing never happened. Maybe the others happened. But this, for me, was very important. Okay, and let me tell you why. When a detective goes out to a crime scene, whether he's a private eye or a police detective, they suspect everyone. That's the way it works. You're not innocent. You're not innocent until proven guilty. everybody is considered a suspect until you can eliminate them as a suspect. In other words, until you verify their alibis. And that's the way you should work this issue as well. You should leave all preconceptions aside and look at it from a scientific point of view, strictly from a scientific point of view. And one of the things that, detectives look at is, the attitude the person has. They just killed his wife. And he says, oh, I want someone to go look for this guy. And then he goes out and parties with his girlfriend. And what are you going to say, that the guy had the right attitude? Or he's got an attitude where he says, well, yeah, my wife died. It's not the right attitude. The right attitude that you should have, you would think the guy has, is, oh, my poor wife, she died, she was killed. Those are normal reactions. When someone doesn't react in that way, yeah, the detectives suspect a lot, And so all I can tell you is this was a bad reaction. And this is on top of some of the other things that happened in there in that documentary, like, to me, okay, that I cannot explain. And that's like when the astronauts pulled back suddenly, like he was lifted from some wires. In some cases, they jumped too fast. And that's what it appears to me right now. I need to investigate that further. I'm going to run it in slow motion to find out if those jerky motions are correct, if they're natural, if they were done in a studio or on the moon. There's also the dust that the rovers, twirl around. They say, well, that shouldn't happen on the moon. I don't know if that's the case. I got to find out that as well. So there are certain things that the documentary mentioned that concern physics, and these are things that I like to look at. They do concern physics. Okay. So one fellow says, he says, Bill, since you were in search of truth, the truth is what is not hidden. Oh, man. Why do these people even come to science? No, truth has nothing to do with science. Truth has to do with belief, with religion, okay? When you prove something, when you have the truth, you're talking about religion. When you know it, when you know the truth, you're talking about religion, okay? And then he continues. He says, believing the that U.S. landings have taken place is a leap of faith. Okay, to some degree that's true. And then he says, I don't believe it's a hoax. I know for sure it's a hoax. And it reminds me of the Three Stooges, where they say, do you think you can make it work, Larry? And he says, I don't know. I don't think. I know. And Mo says, I don't think you know either. So, yeah, and then he continues, he says, so it puts you gullible as a believer, okay, in front of a leap of faith. And me instead as a free thinker who has analyzed tons of original NASA documents and formed his own opinion on the matter. It turns out that he later says that there are no original NASA documents because they were all destroyed. So, these people live with these contradictions. All they have is emotions, and that's a bad sign in science. You really, when you're looking at these things, you have to look at it as a detective. Everybody's guilty. Okay, until you can prove them innocent, okay? And you should keep an open mind. You should go in there objectively. And, it's very hard for people to do that. They have all these emotions in them, okay? This is a problem. Okay, so he comes up with a series of issues that are not very solid, but which are raised by many Moonies, okay? And here's some of them, okay? Official documents, they're lost. And he says, currently there are only copies of the originals. Again, how can he say that he looked at originals and then he says there's only copies? Then it says whether the Russians shared results with the Americans. Well, they share a lot of things out there. They have joint missions, and it's like, there are things that are not top secret, okay? So there's a lot of information shared between the Russians and the Americans out there in space, which have nothing to do with some technical secrets that one side can steal from the other. Okay, so they do share information. Okay, certain information. Mining on the moon, yeah, that's future. We can't talk about that right now. And whether there's been no trip to the moon in the last 50 years, again, there are reasons for that. There's no reason to go to the moon. And that's why they never had to prepare anything in the last 50 years to go back to the moon. You can't see the flag. Well, that's very easily solved. Very easily. They can put a flag on the moon with an artificial mission. They don't need to put an astronaut on the moon. So the next time they go there, they can still put the old flag there in the same place. They say the flag's there, so they can fool you anyways. Okay, so that's not a way of proving to anyone that you went to the moon or not. And then the power of the rockets. Do we have power enough in the rockets to send rockets to the moon? That's a valid issue that does concern physics. Okay, but I'm going to address a couple other issues which have to do with physics. Okay, this is about physics, not about really your opinion. This has to do with something that we should be able to test. Okay, we can test it here on Earth. The first one is radiation. Okay, did the Russians send turtles to pass the two Van Allen radiation belts twice? Back and forth. Okay, so the question is, the Russians did that a few months before the first moon landing or alleged moon landing. The turtles came back alive according to official versions, right? Russian and American, by the way. And so this fellow says, he says there, the USA send human life beyond the Van Allen radiation belts without even a small mole grown or without a tumor or with classic symptoms of radiation. He thinks that if you send something alive like a turtle or a human, the thing should come back, this living entity should come back with cancer. And I think the expectations, the notions that people have about what radiation will do to you, how fast it will do it to you, and at what dosage it will do it to you, they haven't, I think, looked at that at all. Okay, this is where the problem is. And so he says Van Allen radiation belts are impossible for humans to cross. Is that the case? Okay, and so when you go to NASA and to other sites, these are some of the papers you find out there. Okay, and I don't know if you read any of these, but these are things that you would have to read in order to answer these questions. Okay, and here's one. It says radiation doses measured during Apollo were significantly lower than the yearly average of a 5 rem set by the U.S. Atomic Energy Commission for workers who use radioactive materials in factories and institutions across the United States. And so they go through these numbers and they say, look, these are the radiation doses that they would have received. They're way below the, I think it's the 5 rem, average 5 rem, that would start causing problems. These are way below that level. And so to say that, you're going to have cancer because you pass the radiation belts, I think his expectations is what's overblown. Okay, and here NASA says the main operational countermeasures against the adverse effects of radiation is simply limiting astronaut exposure, which means limiting the amount of time astronauts are allowed to be in space. Okay, this is accomplished primarily by shortening overall mission duration on the space station to 3 to 6 months. Okay, so they have these different ways of protecting the astronauts. Some of them involve protection, some of them involve time. They also have this suit which measures radiation, to see how much doses they received and if they've been zapped or whatever. And a couple months ago, I went for an MRI, and I asked the gal who ran the machine. I said, because they walk outside, right? They leave you inside to get zapped. And so I asked her, do you get radiation, et cetera, et cetera? And she said, she told me a little bit about it. She says she has a radiation meter, and every time throughout the day, she carries it with her. And so they measure her radiation, how much dose she gets. And she says it's actually quite normal, because she's outside. There's radiation in the room. She's in that room constantly. She goes back outside. Maybe at some point she might receive, by mistake, some radiation. I don't know. But they monitor that, and she doesn't get cancer because of that. Okay. Even the people in Hiroshima and Nagasaki, it's not, a lot of them got cancer many years later. It's not like they suddenly, start growing tumors all over unless they were zapped directly. Okay, so again, these people have a poor notion of how radiation actually works. But there are more basic things. Here's another one. Okay, this fellow raised. Okay, he raised all the issues, so I'm just going to consider what he said essentially because everybody raises the same arguments. Okay, says today we have a tin of tuna, tin can out there orbiting the Earth in low orbit because humanity cannot do more than that. Okay, so we have this tuna can up there. Okay, it's called the ISS. And the first thing I want to establish, yes, that there is a can of tuna going up there. Okay, so here's this is an amateur photographer, filmer, I guess you could call him, and he filmed the ISS. There's the ISS at night. Okay, and that's what it looks like in one of his photographs. Okay, so he says, look, I filmed this thing orbiting the Earth up there in the sky. Okay, and there's hundreds of amateur astronomers on Earth that film these things and take pictures and so on. And like I said, all you need to do is, here's another version of that. Okay, take your binocular or your telescope, whatever you have, or your friends, right, and take a look and find out if there is out there this thing that you see there, the picture that this fellow took, which is a space station, this ISS, International Space Station. Is this thing out there? So if you confirm that there is such a space station out there, at least we got to say, okay, there's this monster 500 miles out there, right? Or I think 500 kilometers, floating around the Earth. How did we put that piece of metal? Not a little tiny thing. This is not a little tin can. This is a big monster, okay, that's floating out there because you can see it with your telescope. You can do the calculation, how much you see of it. You can say, okay, that thing is big. That's not a kite, okay? The ISS kite, okay? No, that's a real station that's floating out there. How did we do that? Did we do that all of a sudden and we just go one day and suddenly, decide to send the space station out there? No, there had to be many steps in between. And among them, you had to orbit the Earth with some vehicle of some kind. And when you look back, yeah, all those steps were taken, all the way to even putting a man around in orbit. Gagarin, the first one who went into space around the Earth. And so, some people deny that. There's different level of credulity or incredulity. Some people don't believe this, others believe less, others believe none at all. And so you got to go step by step very slowly. And so, here's one thing that this fellow raises, because he's okay, the tin can's floating out there. That's it. They put that out there to fool people. That's a hoax. Okay. So he says, do you think it's possible that a woman with hair fluttering in the air releases dangerous molecules of water inside the space base that orbits the Earth? He doesn't believe that this is true, what I'm going to show now, which this lady, okay, she's an astronaut. She's up there on the space station. She releases a big drop of water and then she swallows it. And he says, how would she do that? That's dangerous because you have all this water floating, could kill someone. So, I mean, is this guy for real? I mean, does he really believe that this is going to kill someone because he releases some water inside the ISS? And, are we saying that this never happened, that this is all green screened? Is that how they did this? Is that the physics behind all this, that she's just floating there and pulled with wires? Each one of her hairs is probably being pulled with wires. Maybe they have a ventilator blowing her hair out. How did they do this? Please explain the mechanism, how they filmed this so as to convince you, on top of the fact that she's floating, okay? And here was the other fellow, this was the same. You can see he's going from one place to another inside the ISS. Did they do that all with wires? I mean, in this little station? Is it all green screened? Is this all made in computer made, photoshopped or whatever? How did they do this? The guy's floating around. He lets go of his, his TV there, his little thing, his Computer, let me make this smaller. Sorry. Make it a little smaller so you can see what the guy's doing there. Okay. Okay, he lets go of his little computer there, okay? And you can see it's floating. So how did they do that? Please explain the mechanism. I want to know the physics behind this. I'd like to do it myself. Okay, so yeah, I don't believe that this was done in a in a gravity scenario. This was done in non-gravity, and that's what the ISS does. So to think that this guy's not in the ISS, well, where is he? Is he in Hollywood? Is this being all done with strings and wires? Is that what this guy really thinks? Okay, so this is real. Okay, and if you don't believe that, do you believe this? Okay, here's this guy again. He's in this airplane that takes a given curve at a certain speed, a certain angle, and the guy floats for 20 seconds in the air. That's it. 20 seconds. After that, he falls back down because this is not an astronaut. This is what is known as a pilot. In other words, people who fly within airplane level, they're known as pilots. Only when you go to a certain level are you known as an astronaut. So these are pilots flying in an airplane, and this only lasts 20 seconds. So you can do this for 20 seconds. The guy you just saw a minute ago, he did it for 45 minutes straight. So to say that, that never happened, that's a hoax, that's all done with wires and strings and whatever, now you got a problem. You got a serious problem. Okay, here's another, I fell to the other side. Give me a second here. Here's this astronaut. He's jumping on the moon. Now, could this have been done with wires? And, you can see him floating around. You say, well, could have been done by wires, no doubt about it. It's a possibility. And, what I did was run it at twice the speed. And here he goes at twice the speed. Okay? So all you have to do, this is obviously, you could do this on Earth and then slow it down, to convince people. Here you see it slowed down. Okay, we can do this on Earth. This could be done in a studio. I have no problem believing that this could have been done here on Earth, but not the astronaut going from one room to another with his little computer floating around. How do you do that? So no, that guy was in zero gravity. Not only was he in zero gravity, he was in zero gravity for 45 minutes straight. Don't tell me that was done in Hollywood. Okay, and so here we have, this is Buzz Aldrin. This was on Apollo 11, okay? And he's doing some push-ups, or like one of the guys in Houston said, well, I didn't know if you did a pull-up or a push-up there, or chin-up, because he says he couldn't tell, but you can see he's floating around, okay? Was this done by Hollywood for NASA? Is that how this was done? Okay, this one, maybe we can still believe. Okay, how about this one? Let me show you this one. Okay, here we have it. Falls to the other side. Give me a second. Okay, here's a flashlight. And Buzz Aldrin just lets go of it. Okay? And then he steadies it, and you'll see what happens to the flashlight. It moves very, very slowly. And also check to see where he grabs the flashlight. He grabs it from places where you would think that there are little threads. Okay, he pushes it. Okay, is that being hung by threads from different places? Because you're going to see that flashlight move around in different directions. In fact, troll around. How does he do this trick here on Earth? Did he do this in a studio? And here's an even worse trick. Here's the standing flashlight. Okay, and watch it how it slowly, very slowly, goes from, stands on its head. How do they do this trick? Even today, how do you do this trick unless it's in a gravity, not a zero gravity scenario? Okay, you can see it's going slowly. And I said, okay, let's see if it's true, because see, for the astronaut that was jumping, I said, okay, I doubled the speed, and I can show that very easily that that could have been done on Earth, no problem at all. What I did with this was, very simple. You can do this trick at home as well, okay? We have a little, my magic wand, okay? And, if you stand this up and let go of it, it falls immediately. It does throw around, but then immediately it stabilizes. It doesn't stay like this, like in this case, the flashlight stayed like this for quite a while, okay? I can't reproduce that with this trick here. So how did he do the trick? Well, tell me the physics behind it, okay? That's what I want to understand. Now you could say, well, he didn't go to the moon. He was in Earth orbit. Great, that's what I wanted to hear. Because he's got to be out there in space somewhere. He's either going to the moon or he's going around the Earth. Okay, those two I can accept. To say that Aldrin was here on Earth in a studio and this was all filmed in studios with the lights from everywhere. No, you're going to have to explain that one to me. Show me how you do that in a studio with the lights and with whatever you want. Okay, so don't tell me that this guy was not in space. That's my point. Okay, this guy was in space. Whether he was in orbit around the Earth or going to the moon, that part can be debatable. What is not debatable is that this was not done in a studio. Okay, this was not Photoshop, which did not exist at the time. Green screen started, by the way, after the 70s. Okay, until then they had blue screen, and even before that, 1898, more than 100 years ago, they started with black screen. They had this black screen and they already had invented it almost at the same time they invented movies. So we could do that. We can do that in a studio. What we cannot do in a studio is some of the tricks he did with the flashlight. We can't do that, okay? So again, you got to explain it to me, the physics behind it, okay? Don't tell me that you believe or you don't believe. I need the physics. I need the mechanism, okay? Okay, in fact, some of the people who rail against, the official version, they admit that these guys went at least into space in orbit around the Earth. Here it is. Let me show it to you. Okay, pay attention.
It is apparent they are in genuine zero gravity aboard the actual spacecraft, necessary to convince the mass media of their authenticity, just not any further than Earth orbit.
Okay, so Buzz Aldrin, he did a little trick there that's not easy to do in Hollywood, okay? Even with strings or wires or whatever, okay? And you can see that they're saying there that the guy was at least in Earth orbit, okay? And here they provide a little bit of proof on that, and that's that the way they filmed the Earth from the capsule is by not filming all of the Earth. It was a nice little trick, okay? I want you to watch carefully because, again, this has to do with physics, with how things are done, okay? And here it is. This is how things are done, assuming you want to fool the public, and this could be one way they did it, okay? So, again, you got to keep an eye on all this stuff because some of these arguments are good to hear, okay? Here it is, okay? Let's look at it.
Here you can see the extruded window, probably 2 inches thick at the bottom. This is because the Earth's shine is coming in at a downward angle. It also causes the Earth to appear to be an irregularly shaped circle, for you are seeing the outside of the window at the bottom and the inside of the window at the top, which together form 2 different sized halves of a circle. Subsequently, this take was never used.
Okay, so what they did was film a portion of the Earth, and they used as a contour the window of the capsule. Okay, now was that done from the moon or on the way to the moon, or was that done while orbiting the Earth from relatively close by and just filming a portion of the Earth and making it look like it was a globe that you were staring at? It's a valid question. Okay, how did they do the trick, if they did the trick? Okay, and why did they show it? Well, that's something else. That's got to do with conspiracy. But the physics of it, that is debatable. That's something we can treat in this channel at least. Okay. Okay, so other issues that were mentioned, here and there, and a lot of people mentioned. Here's one of them: the shadows. Okay, when you look at this from above, okay, look at it from above here, you can see the shadows are parallel. But as he moves the camera, okay, the shadows, depending on the angle, seem to converge. They're not parallel anymore. Okay, look at it one more time. From above and from a different angle and below. And again, with a terrain that is not completely straight. Okay, so, shadows, I don't know if that's a good argument, because again, people make too many assumptions of what they think they should be looking at. Okay, and here this guy can explain the mechanism of why we see these lines which are not parallel depending on the angle. Okay, and again, one of the things you don't see is double light. If there were two lights, for example, right, you should see two shadows. Okay, and that's not the case, because they say some shadows go this way, the other shadow goes that way. Well, if you have two lights, you should have at least two shadows, and you don't see that. What did they do? Rub them off the film? So again, how do you do this? Tell me the physics behind it that underlies this. Okay. Another one was the Falloff of Light. Okay, and here you see what they're talking about. They're saying, look, you got a shiny part at front and a darker part at behind. They have this Falloff of Light. Okay, they say what you should see is something like a desert there. You should see the sun shining evenly across the whole landscape. Okay, so they say this is proof, evidence, that Apollo 11 never happened on the moon. Okay, but here I show Apollo 15. Okay, here it goes. And you can see that they've got this rover, this golf cart going around the moon, and it's pretty even to be there. So are we saying that Apollo 11 never went to the moon, but Apollo 15 did? I mean, how did they film this? Double light? Okay, so again, you can't be picky with your information. You got to put all the information down. If you see something that denies your theory, you should put it out there. Okay, and here you can see a comparison of both of these. Okay, Apollo 11, 69 on one side, Apollo 15 on the other. And you can see that the surface there looks pretty much like that desert that they filmed there. Okay, so I don't know. I don't think this is a good argument to raise, and that's one of the arguments that the people who made the film did make. Okay, and I don't know. You got to look at all data, the one that certifies your theory and also the one that goes against your theory. Okay. Okay, so what can I say as a conclusion? You got to be open-minded. That's what you got to be, okay? And you got to be available to think in different ways and in different scenarios. But here's my conclusion for you, for anyone who wants to act as a detective to find out, objective detective, to find out if the moon stuff ever happened, okay? If he wants to be honest with himself, first, don't jump to conclusions. Okay, that's the first conclusion. Okay, then be objective. Remove all emotions. People are very emotional about conspiracies, okay? And you got to stay away, and if possible, from the conspiracy, and focus primarily on the physics of it. How did they do it? Okay, that's what you really want to get to. Okay, even if they fooled you, even if it's a hoax, you want to know how they did that as well. Okay, so how did they get to the moon? Okay, if they got there. And how did they make a hoax if they fooled you? Okay, both. You have to explain the hows in both cases. Okay? You have to start by viewing things in light most favorable to your opponent, to the other person's view. Okay? Be critical of your own theory. Okay? Criticize yourself. Don't just say, oh yeah, that's a hoax and blah, 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 and just keep going. No, you got to be a little more paying attention to details and try to see if you can make holes in your own theory. Okay, investigate what is unclear. Okay, there's some things I cannot explain, and that's why I'm reserving a little bit of doubt there, because there are some things I cannot explain. Just as simple as that. And don't throw the baby away with the wash water. You don't reject all of it because of one little detail or whatever that made you change your mind. Okay, I don't throw the whole baby with the wash water. And what's my reasoning is that we had all these intermediate steps. Okay, we sent first a rocket out there into space at some point in time. It orbited the Earth. Then they sent a dog. Then they sent a man. Then they sent a woman. They went through all these steps to say that none of that happened. That it's all a hoax. You're throwing away the baby with the washwater. You're saying, well, you don't believe it, blah blah blah. But how is it that we have a space station, an ISS, a monster? What is it? Tuna can orbiting the Earth. How did we get it up there? I mean, are you just going to say that one day they just woke up and they said, okay, let's put all these pieces of metal together and just throw it up there? Is that how it was done? So you got to explain all the steps that led to the ISS. And that's when you're going to find out that there were many trips by rockets, by probes going into space. Did we ever take pictures of Venus, of Mercury, of Mars with artificial vehicles? I think we did. And so we do have rockets powerful enough to take us to the moon, certainly to Mars. Okay. And I mean, they have all these ICBMs. You think that they can't go from Russia to the United States and from the United States to China and so on? Of course they can. And you think that can't happen? Well, I don't know. I got news for you. You better sleep with an umbrella. Okay. Okay, let's move on to the subject matter of today. But I had to cover that. Sorry, guys, for a lengthy discussion there. But the moon landing is pretty important stuff to a lot of people. And there's the physics part of it that interests me. And I think we should cover that to some degree here. Of course, I'm not going to be as lengthy with the moon landings in the future. But I do want to cover certain aspects when something comes up. If someone comes up with some kind of evidence, proof, or some mechanism, really, that's what I'm looking for, physical mechanism, I'm going to address it, okay, because I think it's pertinent to, at least to this channel. Okay, let's go on with location. What is location? Well, what we have here is a fellow who asked a question related to distance the other day, specifically distance traveled. And he asked this, or he essentially tried to define what distance traveled is. He says the distance of a moving object relative to the medium it's traveling through. Okay, an airplane uses air to measure its distance traveled, just as a boat uses the water it floats in. Okay, so what was my reply to this? Well, I'm saying that physics doesn't deal with measurement and with distance traveled. Okay, especially when it's a numerical value. And so this was my answer. I said, in physics, we don't measure. In physics, we explain. It's math that measures and introduces numbers and units. Okay, that's why it is absolutely necessary to define what physics is about before we begin to do physics. It is the mathematicians, okay, which took over physics since the days of the Greeks, that veered the discipline in the direction of math. This is the reason not a single mathematical so-called physicist ever figured out qualitative stuff such as mechanisms and causes. It's not part of their job description, even to this day, by the way. Yeah? And yet, why did they attempt to provide a physical interpretation to their equation in the first place? The answer is because otherwise their equations are irrelevant. Okay? If they're going to do measurement and then they're going to do an equation that somehow reflects those measurements, so far they have done absolutely nothing that is of any concern to science, specifically to physics. They haven't done anything that's of any importance to physics. In physics, we need to explain the cause, the mechanism. Once we explain that, we're done with physics forever. Physics, science is not an ongoing process of discovery. No, we stop and we explain. If you can't explain, you're not a physicist. Get out of the way. Okay? You're bothering us. You're in the way of progress. Okay? You need to explain. And once you explain, we're done with physics. We're done. Okay? You got a better explanation? Great. Bring it on. Okay, so how do we start this thing where we ended up with distance? And before that, I discussed, position and what is it? Place, the word that the Greeks used. And so I started out with a little summary of what happened in the days of the Greeks. They weren't the first, by the way, but they did document what they thought about all these things, okay, especially about positions, which a lot of people equate with location today. So let's make sure we cover, the steps that led to that notion that position and location are the same thing. And it started with these Greeks, okay? We had the Eleatics there on the upper left, and they said that everything is immovable. There's nothing that moves in the universe. Why? Because, there is no such thing as an empty space in which something can move into. Okay, so that was the issue. So they said, there's no such thing as empty space. Everything is covered. When you move something, something else moves in there, but the only way it could move in there is if you had an empty space. And they said that's impossible, so they said there is no motion. That was their conclusion. What did the atomists like Democritus and Leucippus come up with? Well, they said, well, there has to be some space because there's obviously motion in the universe. And so they treated these other folks as idiots. They said, no, these people are saying there's no motion. What do you mean there's no motion? I'm moving my hand right now, What the hell are you saying there's no motion? Plato thought that matter and space are the same, okay? And so he said the participant and space are identical. So he thought that space was a thing, okay? And that matter kind of displaced space, the emptiness. And what did Aristotle come up with? Well, he said the existence of place is held to be obvious from the fact of mutual replacement, okay? You can replace something in water where air was, for example, okay? What now contains air formerly contained water, so that clearly the place or space into which and out of which they passed was something different from both. So he thought there was something, he called it existing. That's the adjective he says. It's space, this emptiness exists. It's a thing. Even though he said that in order for something to exist, it has to have location. And so he said space exists, and I don't know what the location of space is, but he never answered that question. He just said it exists, and because it exists, something can move into space, into nothingness. Okay. So that was his conclusion. A few hundred years later, we have these three other fellows. I talked about them in the past, so I'm not going to go over them in detail. Okay. One was Newton, and he said place is a part of space which a body takes up and is according to the space either absolute or relative, okay? And he believed in absolute space, and I guess it was Einstein who turned that over and said, no, it's all relative, okay? Positions properly have no quantity, okay? Nor are they so much the places themselves as the properties of places, okay? So he started bringing numbers into this where I don't even know what quantity has to do with position. Shouldn't have, but you'll find out why in a minute. And a short time later, less than 100 years later, we have these two fellows, Hume and Kant. And Hume said, space does not exist independently of objects. You cannot conceive of space in the absence of objects. Okay, so this was his notion. So, again, they were all trying to figure out space and, again, position, I guess location of things in space, okay? And what did Kant come up with? Well, he says you can't imagine the absence of space. So the first guy said you can't imagine the absence of objects. This guy said you can't imagine the absence of space, okay? And so he thought about in terms of infinite space. Again, he thought it was some kind of object. And he said, well, it's better not to even think about these things because we're not going to solve them. Okay, and yeah, I think we can solve them if we define what space is, and once we define space, then maybe we can talk about position and location. Okay, so that's the way it works in science. And these people never defined space, and they started talking about space without really defining what they meant by space. They just wondered whether it's an object and whether it exists. But they never started at the square number one, which is, please define the word space if it's a concept, and otherwise point to it if it's an object. What is the shape of space? If you can't point to it, then it's a concept, and you got to define it. And so they never did either. So they didn't start at square one. That's why they never figured it out, and we're talking about there at least the 18th century. Okay, did we do anything better since then? Well, then we really made a mess of things, and here we have the relativists, and they said, look, we're going to be doing length contraction. We're going to contract space. Okay, we just need to make that thing travel at the speed of light or close to the speed of light, and you'll see how it contracts. Okay, like an accordion. And what did the quantum folks come up with? Well, they said space is made out of particles. Okay, it's got all this junk in it. One fellow called it the Dirac sea in his own name, Paul Dirac. And they say that particles come out of the vacuum. Okay, in other words, the vacuum is made out of particles that can come into our world. They're known as virtual particles momentarily. Okay, they come into our world momentarily, these virtual particles, and then they go back to being part of space. In other words, they think that space itself is made out of particles, meaning that somehow they equate this with an object, with a thing. They're saying space is a thing. And so you can see the trouble this is going to create for both position and location, because how can you say that you have a certain location if what you're doing is taking over the spot occupied by particles, I assume? Are you displacing the particles aside and occupying what? Nothingness? If nothingness is made out of particles, what are you occupying? Are you displacing the particles that make up space? And if you travel close to the speed of light, are you shrinking or taking up more space, taking up less space? What are you taking up if you haven't defined what space is? So again, we have a problem because none of these people ever defined words. What was it? What I said earlier? I said that, one of the first words you have to define in science is the word definition itself. You need to know what a scientific definition is. If you don't define the word definition, then you can't even start, because you don't know what a scientific definition is. You're just going to go to the ordinary dictionary, pull a definition out of there and say, oh, I'm going to bring this into science. It sounds good to me. Well, if it sounds good, be able to defend it. That's the way it works in science. If you can defend it against all attacks, then you have a definition you can use. Otherwise, you can't use that definition in science, especially for the foundations of science. Okay, so what is position? Well, position is essentially a game of battleship. That's what they think it is today. Okay, position is like a portion of space where you're going to put a dot in there. Okay, you're going to put not even a dot. What you really are putting is an ordered paired or triplet or whatever, quadruplet. You're going to put a couple numbers that designate how to get there, how to get to that spot. It's not the spot itself, but how to get there. Okay, so they have a series of numbers. They say, it's like battleship. You have H1 versus A8, and you put a dot there. You put an X or a dot. If there's a battleship there, well, you put a dot. If you have water there, then you put an X. Great. It's the game of battleship. That's all it is. Okay, and so what is a position under this notion, this definition, or this way of presenting things in mathematical physics? And here it is. It's essentially how to get to the treasure chest. Okay, what you have is, in those two numbers, if you're using an ordered pair, what you're saying is not the position of something. What you're saying is how to get to that position. You're giving a set of instructions of how to find a treasure chest. Okay, that's what position is under mathematics. Okay, so here we have the way it's represented. They use the dot to represent position. And again, what they're doing there is something which is irrational. They say that a position is defined, or is what they're going to use is an undefined point. They're going to say, we're going to put a point there. Well, what's a point? Well, a point objectively is what you see there. It's a dot. It's got shape. Okay, so it's an object under the definitions of physics, under the definitions of science. A dot is a thing. Okay, because it has shape. That's the only reason. And but a position is a concept. If you take it as how to get there, that's a concept. Now you can use something else, like you can say, well, what if I take the center of mass of the elephant? What you want to do is locate where that center, the elephant is an irregular shaped thing. Okay, so the center of mass is not in its trunk or in its feet, it's somewhere in its body. And so you want to say, what's the center of mass of the elephant? And there I'm going to put a dot, I guess. But what are you saying? You're saying how to arrive from a set of coordinates, reference frame, okay? Frame of reference. From that frame of reference, you're going to say, this is 0, this is my starting point, and I'm going to go so many meters to the right, maybe on the x-axis, then so many upwards, and that's how I get to the center of mass of the elephant. And you put a dot there, and you say, okay, that's the center of mass of the elephant. Again, it's how to get there. It's not like, I mean, how else, what else, what other notion, what other definition could you have then for position of the center of mass, unless you relate it to some frame of reference and use, in this case, the x and y coordinates to get there. There is no other meaning to that. Okay, so position is, how to get there. It's not the dot itself that you're representing, in this case, the center of mass of the elephant. What you're saying is how to get to there, to that place. Okay, that's what this has become. Okay, so what happens? Well, if that's what position is, okay, is that the same thing as location? Are we locating something, or are we talking about the position occupied by either the elephant or the center of mass of the elephant, which makes no sense whatsoever because it's a concept. You can't say what is the position of the center of mass. Well, you can only tell the position if you have an XY coordinate system and you say so many feet this way, so many feet that way. But if you just put a dot there, what is the meaning of that dot? Okay, it only has meaning if you put a set of coordinates. Okay, and so this is the situation. Is position the volume occupied by an object? Are they synonyms? The volume itself occupied by, I don't know, the pencil? Is the pencil the same thing as the position, the volume it occupies? Or is the position the steps necessary to get there, to reach the dot or whatever you represented the pencil with? Okay? Because if it's B, if it's the steps necessary to get there, then it's a dynamic concept. Okay? You're talking about displacement. You're talking about motion. Okay? Meaning position, which is a static concept, or in the minds of most people, it's a static concept, is actually motion. Because what you're saying is, I'm going to give you the set of instructions of how to get there. Take this road this way, so many miles, and so many miles that way, and you'll reach the treasure chest. That's what you're saying. You're giving them a set of instructions on how to get there. So it's not the volume occupied by the treasure chest, it's how to get to the treasure chest. Okay, so how do we do it in science? Well, first of all, we distinguish position from location. Okay, and the way we do it, we have to define them. So position is the volume occupied by an object. It has no importance in physics because it's the object itself. Okay, and we have no use for numbers. Okay, don't tell me how many steps to get there because it's irrelevant to the issue that we're trying to resolve here. Mother Nature never went to school. She doesn't know anything about math. She's ignorant completely in numbers. Mother Nature just works with objects every day. She moves them around from one place to another. That's all she does. In fact, she doesn't even do that. What she has really is every frame of the film is what Mother Nature does. Location. That's all it is. An object at a given distance from all the others in the universe. So Mother Nature lives what we can say in the now. Now meaning just a cross section of time, not an interval of time. I don't care how small you want to make it. An interval is many, many frames, no matter how you look at it. We're not talking about many frames of the movie. We're talking about a single frame of the universal movie, a cross section of time, so to speak. Whatever's in there is static. Nothing is moving. All we have is distance between objects. We call that location. Mother Nature only understands location. She doesn't understand numbers. She doesn't know anything about meters, and she only knows about separation, which was the distance between objects, separation. Distance traveled, no. Mother Nature doesn't understand that either, especially if it's numerical. Okay? Because for that you need several frames of the film. Okay? And Mother Nature just lives at the cutting edge of the past, you could say. Right where the past meets the future, we call that the now. The now is not an interval, even though, it's You could think of it as an interval of time. But no, the now is the cutting edge. It's a cross section of time. It's a single frame of the universal movie. Everything is static there, and that's the only thing Mother Nature understands. So location is qualitative only. What is it? Well, in order to get to the definition of location, you need to have these words defined first. You need to know what an object is. Without objects, you have absolutely nothing in the universe, meaning you only have space, which is nothing, which is that which has no shape. So you can't, nothing is happening, nothing you can measure for sure. There's no distance, no location, no anything, because you need the object to have any of those properties. Once you have the object, okay, now you have distance. What is distance? Distance is just separation between objects. You don't unroll the measuring tape and say it's so many meters. That's not distance. That distance traveled by the tip of your measuring tape. We're talking about only separation between the centers of the object, the surfaces, whatever you want. Doesn't matter. That depends on you. But it's separation. Once you have separation from this object to that object to all other objects, then you have location. Now you have the set of distances, the set of separations from one object to all the others. So far, these three words are static concepts. They only have relevance in a single frame of the universal movie in a cross section of time. That's location for you. Okay. So, forget about this notion of position. Position, especially if position means motion, synonym of motion, saying that, it's how to get there. That's walking. That's running, that's flying, that's swimming. Those are verbs. Okay, so position is how to get there. You're not talking about a static concept, and for sure you're not talking about position. Position, anybody's idea of that, at least in ordinary speech, is that it's a static concept. And these people transformed it into a dynamic concept, but we already have a word for that. We call it motion. So what is this position nonsense? And even if you're going to put numbers to it, we call it displacement or, distance traveled. So what is position? Again, no meaning whatsoever if you just put a pair of, ordered pair or whatever, X, Y. Okay, let's look at the questions people made. Okay. And here they are. One fellow said, if not by evidence, then why would anyone choose your hypothesis over any other hypothesis? You're right. Choosing is opinion. Opinion has to do with religion, not with science. So, evidence is part of religion. Okay? Evidence has to do with convincing, persuading you, asking you to change your mind, recruiting you to the congregation. That's what it has to do with. If evidence is not needed, then saying God does everything is just as viable as any scientific theory. Exactly. Okay? It's just as viable. Whether you believe it or not, it's your personal problem. But, I'd rather believe in God than in space-time, because that's even worse, because here you're saying that, assuming, that's what you vouch for, what you're saying is that here we have this concept, and that's causing gravity or whatever, time dilation or any of those. No, I'd rather believe in God. God, at least, I can imagine. It's that fellow there with a beard, okay? That I can imagine. I cannot imagine space-time, because space-time is a concept, and they represent it with a fishnet, canvas, trampoline. What sense does that make to represent a concept with a fishnet? Okay, so if I had to believe somebody, I'd rather believe the guy on the left. But then again, it's evidence has to do with belief, so we don't care about that. Well, the way we do it in science, we say, let us assume. And we can make an assumption that God exists. That assumption you can make. You cannot make an assumption that space-time exists. Okay, because space-time is a concept, and exist requires an object. That's why you can't use space-time at all to make your case for gravity. Okay? You used evidence to conclude that the International Space Station is real. Because we weren't talking about a theory, and we weren't even talking about anything, just belief. So we were talking about religion. What someone mentioned that it's conspiracy or politics or whatever, that's what we were talking about. That portion of that segment of the dissertation had to do with conspiracy, with belief. Okay, so yeah, I did use it for that, not for science. Okay, let's put it in the right context. If your theory predicts a new phenomena, predicts, then you go searching for that phenomena. No, only, what was it? An idiot was the word that we used, okay? That's the person who does predictions and who goes searching for phenomena that are predicted. We don't do predictions in science. In science, we work with the past, with what happened. We try to explain what happened. If you explain something that will happen, you're basing it on experience, meaning the past, and again, you're explaining the past. You cannot explain why something will happen in the future. You can predict it, which is a description. You cannot explain it. If you can explain it, you're drawing on experience, which is the past. Okay? So we cannot explain the future, something that will happen. We cannot explain it. If you can, you're not talking about the future anymore. Now you're talking about the past. You're talking about your past experience. People don't understand that. It takes them a long time to understand that argument. If that phenomena actually happens, then that new knowledge can be used to make new technology. Okay, where do we put knowledge and technology? Well, up your nose holes. That's where we put it. It has nothing to do with science. Okay, so this notion about making technology, we do that by trial and error. It has nothing to do with science. Science is explain the mechanism. Knowledge, what was one of the words in the idiot list? Knowledge. When you know, you believe. And when you believe, you're not doing science. So don't bring that word into science. Okay, here we have another fellow. He says, there is no reason more than chemical interactions as to why, what, how. So he's saying that gravity works by chemical reactions. Is that how gravity, is this a chemical reaction? Okay, is that the why that underlies magnetism? My God. Science must be useful. No, it's technology which is useful, not science. Science is useless. Hopefully it's useless, because the only purpose of science is to explain so that we understand. That's it. If you can make some use of that, well, that's your go with technology. We don't care about that. Science is not supposed to be useful. Science is only supposed to be understandable. Okay? And to be useful, it needs to be supported by evidence. Again, religion. Okay? Evidence is an element of religion, because you're trying to convince the jury, you're trying to persuade, you're trying to change their mind, you're trying to get them to vote for your version of events. Science does help with technological development. I don't know if it does or not. It shouldn't. It's not its purpose. That's not the purpose of science. The purpose of science is to understand. Try to please understand before one of us dies, as Mr. Faulty would say, John Cleese. Okay, what if every time, instead of saying magnetic field, you had to say the electromagnetic double belt helix ropes that connect every atom to every other atom? Now, this is not a question of semantics, of saying I'm going to make life difficult on you because I'm going to put this long sentence that you have to replace the word field every time. Now, you need to understand that field is a concept. There's no physical standalone object called a field. You can't say the field did this and paddled the charge to the other side of the universe. You cannot use the word field as a baseball bat. Okay? So this is where the problem is. These people want to use field as a physical object. That's a field there. Okay, you have the magnetic field and the electric field. What are you staring at? You're staring at vectors. What is a vector? Magnitude and direction. A number that somehow is pointed somewhere. That's what you're seeing. You're seeing a bunch of arrows, a bunch of vectors perpendicular to each other. That's what we're showing there. And they call that a wave. What is a wave of? Wave of vectors, wave of numbers. That's what a field is, or a pair of fields in this case. Okay. No, rope is a thing. It's an object. It's got shape. Go. You can prove this to yourself. Very easy if you want to convince yourself, right? If you want to do a little religion, go to the hardware store and ask for a field and see what they sell you. Or maybe they put you away, bring the men with the white jackets. And then ask them for a rope, and they'll sell you something that looks more or less like this. Yeah, what you see there. So yeah, you can ask for a rope because it's a physical object. You can ask for a field or a pair of fields, twine fields. They won't know what to sell you. Okay? Can you order it for me? Yeah, maybe, yeah. Okay, another fellow says, every formula in physics which includes constant is false. Okay, formulas, he says, anything that's got a constant is false. Okay, why? Because there is no constant in nature. Okay, the most accepted constant, pi, 3.14, la la la, is not a constant since nobody can determine its exact value. So this fellow says that none of those constants, the mass of the electron or the proton, the Planck constant, none of those are constants because they have, as they say, infinite numbers, meaning you can count incessantly or put incessant number of decimal points or whatever. So he says there's no constant. And we're going to destroy his religion right here and now. Okay, and it's that we don't need to do any math, we don't need to do any measurement to figure out that there is a constant in nature, and that is the torsion along a rope, an electromagnetic rope, or any rope for that matter. Here we have a rope. Okay, let me pull this out momentarily so that I can show you this. Okay, here we have a rope. It's a fixed rope. You can see the ends of it. Okay, so that's all there is. And I control it more, make more links, each link smaller. The inverse relationship between frequency and wavelength. That's what you're seeing there. What we call link length, and number of links, meaning the frequency. And now we untorque it, and now we have fewer links, and each link is longer. I always use the same amount of rope. There's no more rope than this. Okay, so yeah, we can figure out why light travels at 300,000 kilometers, whatever. I don't care if it's 301 or 300 or 299 thousand kilometers per second. It doesn't matter to us the exact value. All we can tell you for sure is it's a constant. It's a constant speed because it's a rope that's only changing the number of links and the size of the link, the length of the links. That's all we're doing. So yeah, light travels at a constant speed because light is mediated by a rope. Once you put the rope in there, you can conclude that. If you do it with particles or waves, transverse waves or whatever waves, spherical waves, then you cannot reach any conclusion. Then you're right. But if you do it with a rope, you're wrong. You're simply misinformed. Okay, so just keep that in mind. And yeah, here you see the picture again. Okay, for a given length of rope, okay, you can have either a same number, you can have a given number of links, and you have more of them if you torque it more, and you have fewer if you untorque it. Okay, and so for a given length of rope, you can have different sets of links and length of links, link lengths as we call them. Okay, so yeah, that's what happens with light. Light travels at a constant speed because torsion is fixed. All you can do is change the number of links in exchange for the length of the link, period. We're done. Okay, fellow says, time is not different from space. Okay, and I guess, again, he gets that from people like Hawking there, Stephen Hawking. Time is the measurement of displacement of an object in time. That made a lot of sense. And yeah, that's where you get it from people like him who say, in relativity, there's no real distinction between the space and time coordinates, just as there is no real difference between any two space coordinates. Yeah, for them, it's all the same. That's why they don't see any difference between coordinates and dimensions, vectors. It's all the same to them. There's no difference because they all have magnitude and direction, and they're all dynamic. All of them, And so, yeah, that's why these people can't tell the difference between anything. Okay, final issue. Could this rope theory of gravity also be possible to happen on a flat Earth? Oh, my God. Oh, my poor God. No, I cannot imagine the sun and the moon there, rolling around a flat Earth. Why? Because, see, ours is the only theory that can explain, okay, why water and air curve around the Earth. You can't do that with relativity. You can't do that with quantum mechanics, string theory. None of those can explain it. Electric universe, they cannot explain that either. The John Chappell Society, none of those people can explain it. The only reason that water and air curve around the Earth is because the Earth is a globe. And then every atom of air, every atom that comprises water, is bound to every other atom that comprises the Earth, including other atoms of air and other atoms of water, like you see there. So no matter where you put that little red bulb, which is representing an atom, it's connected to all other atoms. And of course, everything tends towards the center of the Earth. Okay? And so how do you do that with the flat Earth? There you have your flat Earth, okay? And what do you think? The moon and the sun are just kites that you swing around the ropes? Is that how it works? No. The gravity is the only way you can explain gravity is with spheres. Okay, that's why the entire universe is composed of spheres primarily. You got some smaller objects like, maybe asteroids that have irregular shapes, but anything that has a certain size is roundish. And it's roundish, I'll tell you why, because it was once a star. That's why it's round. Anything that you see round out there was forged as a star, and what you're seeing today is a cinder of that star. And with that, I'm going to see you next time.